I welcome all the respected members, students, faculties, and industry professionals for today's guest lecture on engineering for future sustainability and its research perspective. So, in this guest lecture, we are going to discuss about what are all the future recent trends, advanced digital technologies, and information uh, communication system that strongly supports the engineering process for better improvement in future. We will move on to the session objectives. Before going to start the background of the subject matter. So our today's session objective, first we are going to primarily discuss about how sustainable engineering will be addressing the global environmental challenges such as climate change, resource depletion, and pollution. Our next part of the discussion will be how to analyze different technological innovations, say, for example, integration of AI in sustainable engineering applications, then integration of AI in renewable energy systems, smart manufacturing, and green materials. So these are some of the emerging technological innovations, how we can equip the artificial intelligence presence for for having better sustainable development in future. Next one, to evaluate various engineering strategies and design approach that promotes the efficient use of energy, materials, and resources in industry as well as infrastructure systems. Investigate the application of digital technologies and optimization techniques for improving the sustainability in engineering operations such as logistics, manufacturing, and supply chain system. Using optimization technique, we can improve the performance of the digital technology for the following areas like logistics, manufacturing, and supply chain. At last, study and analyze the real world case studies. So, how it demonstrates the implementation of sustainable engineering practice in various industries. So, these are our key objectives for the proposed discussion for today's guest lecture topic. Now, we will directly get into the background of the topic. So, what exactly the sustainable engineering means? It primarily focuses on designing as well as implementing advanced digital technology in order to meet the present societal need while preserving the environmental resources for future generations. Engineers are now integrating most environmentally responsible product design, highly energy efficient, and integration of digital technologies into the complex modern systems. The concept of sustainable engineering emphasizes minimizing the environmental impact while maintaining economical growth and social well-being of the people. So, due to the advancement in artificial intelligence, renewable energy systems, smart manufacturing, and circular economy models, so these areas have shown a significant transformation in the engineering field. So circular economy model means reuse the waste materials into an usable form of another different kind of commodity. Whichever the materials that are found in environment as waste scrap items, those waste can be recycled and reused again and again, such that we can able to improve the environmental safety. At the same time, we can put an end to the pollution hazards due to the dumping of waste materials in the surrounding environment. This is what circular economy model. Now let us see some of the basic principles of sustainable engineering. First one is resource efficiency. So efficient use of raw materials, water, as well as electrical energy that are available in industrial process, mainly aiming for reducing the waste and environmental impact. So the term sustainable engineering should be coined in such a way that we need to improve the resource efficiency of a complex mechanical system or a process by reducing the waste and also considering the big environmental impact in terms of external hazards or pollution. So we need to reduce all those challenges. The next one, life cycle thinking. Every products are designed by considering the entire life cycle starting from raw material extraction to disposal, sometimes recycling. So we need to perform life cycle assessment for various product in such a way that so we have to upgrade the technology as well as bring some introduction of new smart materials for developing new product. Next one, engineering importance in environmental protection. How to protect the environment from the engineering point of view. So it is the duty or responsibility of every engineer to develop an innovative solution that must minimize the pollution, carbon emissions, as well as ecological degradation. Next one is economic viability and social responsibility. So whenever you implement a new advanced technology in order to make the environment to be more resilient and sustainable, first and foremost thing, we need to think from the cost point of view, whether the so-called technology can be made as economically feasible one or not over the large landscape implementation. Next one is social responsibility. Engineering solution should improve the quality of human life and also support equitable resource distribution. So next to the principles of sustainable engineering, now we will move on to the technological innovations in sustainable engineering. So here are some of the recent technology. So that is closely coined to the sustainable engineering principle. Let us see how. So first one, renewable energy technology. So renewable energy plays an important crucial role in reducing the dependence on conventional fossil fuels. So here are some of the key technologies that are listed out here for your kind reference. So use of solar photovoltaic systems, modernization of wind energy generation, use of hydrogen energy systems, and the need for bioenergy technologies. So with the use of these advanced technology, we can able to reduce the greenhouse gas emissions by providing sustainable energy alternative to the society. Next one is smart manufacturing and industry 5.0. The modern manufacturing systems must integrate digital technologies and sustainable principles. These are some of the important innovations as given here. So integration of cyber physical production system, then introduction of digital twin technology in optimizing the manufacturing process, then use of AI driven optimization for better decision making process, then cobots, that is collaborative robots. So the ultimate aim of smart manufacturing is to reduce the manufacturing waste by improving the productivity and enhance the energy efficiency of various production process in the industry. Next technology innovation, artificial intelligence and optimization. AI and optimization algorithms are most widely used nowadays in order to improve the sustainability of complex engineering systems. The following are the various research application areas where we can apply AI and optimization algorithm. Supply chain optimization, smart transportation systems, predictive maintenance, then energy management system. These are some of the emerging research applications where we can use optimization algorithms like genetic algorithm, tabu search, ants colony optimization algorithm, and simulated NLP. So these are the tools that are most widely used to enhance the system efficiency by reducing the operational cost in real practice. Next technological innovation is on green materials and nanotechnology. So the development of most environmental friendly material is required nowadays, and that is considered to be another important concern in innovation area. Following are some of the examples that is listed here: biodegradable polymers, nano-reinforced green composites, recyclable construction materials, lightweight automotive materials. So by using such things, we can enhance the mechanical property of any system by reducing totally the environmental impact. Next one is smart cities and sustainable infrastructure. Generally, urban engineering solutions mainly focus on creating a sustainable and comfort living environment for the people. So these are the technologies which comes under the sustainable engineering. Intelligent traffic management system, transportation system, then installation of solar lights, street lights, then smart grid electrical system, sustainable water management, then energy storage building. So these innovations contribute to reduced energy consumption and improved urban sustainability. And now we will see a few note on what is sustainable logistics and supply chain engineering. So far we saw about the different innovation technologies applicable for sustainable engineering. Followed by that, we will see how sustainable engineering more suited for logistics and supply chain operation. And here also more number of research work is currently going on at present. So whichever operation you take in engineering process mechanism, logistics will be the most important role played in sustainability. Say, for example, you want to shift or transfer the item either within the company or from the company to any warehouse location. We need a transportation system, and that must be of highly intelligent and responsive to the environment. So, following are the modernization in logistics and supply chain system. So, green transportation system, then utilization of route optimization algorithm for path planning, then use of electrical vehicle logistics, carbon footprint monitoring. So by using optimization algorithm, we can able to solve these areas by providing a reliable solution by minimizing the fuel consumption and improving the distribution efficiency in logistics. Now let us discuss some case studies on sustainable engineering and smart cities. So case study 1 here, we are going to discuss about the smart city development in Singapore. So we all know that Singapore is one of the world leading smart cities in implementing advanced sustainable engineering solutions. So these are some of the key technologies that are already in implementation. So they are relying upon smart traffic management systems in streets, and they are using sensor-based environmental monitoring, then intelligent public transportation system, then use of energy efficient smart buildings. So these are some of the key technologies they have already implemented in actual practice. So what are the big impact out of this advanced technology? So reduce traffic congestion by using real-time data analytics improved energy efficiency in urban infrastructure, enhanced urban planning through digital simulations. So, what is the so-called outcome for smart city development? So, lowering of carbon emissions, efficient balance of water and energy management system, and overall improved quality of human life. This is one such example. Another example, introduction of smart logistics and warehousing in Japan. So mostly several logistic companies in Japan rely upon AI-driven warehouses, robotics warehouses, in order to optimize several supply chain operations. So here are some of the technologies in live practice. Autonomous warehouse robots, AI-based inventory management tracking system, automated pick and place systems, smart logistics optimization algorithm. And so some of the promising results they have given. So through smart automation in logistics and warehouse that lead to increased warehouse productivity, reducing the wastage in the operational cost. So the introduction of these two sample case studies so illustrates the importance of sustainable future for engineering and what are the modern innovation we have to do it. So that is left with the future generation. That is, I mean to say, the next future generation engineers. Now let us discuss what are the challenges in sustainable engineering. Even though there are many significant process as well as so many advancement came, but the challenges remain still exist to occur. So the following are the challenges: lack of sustainable infrastructure, high capital investment cost to modernize the various technology futures, then lack of regulatory and policy barriers, technological limitations in energy storage as well as energy management systems, and limited awareness in developing regions. So these are some of the challenges. So it is all left between the engineers, policymakers, and industry stakeholders. So they have to collaborate with each other in order to find out suitable solution for these future challenges. These are some of the future research directions. So the future research in sustainable engineering mainly focus on use of AI application with a sustainable manufacturing product, development of advanced energy storage technologies, circular economy based product design, carbon neutral transportation system, use of smart logistics and autonomous delivery network, sustainable material using nanotechnology. So these are the future research direction, or we can say future scope. So a lot of opportunities are there for conducting a detailed research studies, and these research area going to play a highly dominating role in achieving the global sustainability goals. So before I moving on, I would like to give a recap about today's the guest lecture. So initially we introduced what do you mean by sustainability concepts in engineering and what are all the key developments taken place in engineering in the recent past by introducing so many key innovations. Then we saw about the future challenges of sustainable engineering. So in nutshell, I can say that sustainable engineering represents a transformative approach in order to address the global challenges, say environmental and economic challenges. And following technological innovations such as renewable energy systems, AI driven optimization, smart manufacturing and green materials will definitely reshape the modern engineering practices. The future engineering research must focus on developing a highly intelligent, fully integrated, environmental responsible product systems that must ensure sustainable development for next future generation. So with this, I end my today's the guest lecture. At this juncture, I would like to extend my special thanks to existing researchers, young and dynamic academicians from various colleges, and senior industry experts. They have done a lot of studies and contribution in the fields of sustainability as well as smart technologies, renewable energy, both national and international level. So they have provided a lot of important insights for my presentation. So I have to thank all those people. So thank you all. And this is about me, who I am, what I'm doing right now, what are all my present research working areas. So everything I have listed out in nutshell for your kind reference. And these are my present research interest which I am focusing on. So with the above all, once again, I thank all the participants. So we will meet in the next upcoming the virtual session. Thank you all.